Hello, welcome back to another live PEP class. This evening, we're going to be looking at another performance task, Wednesday, of course. So we're going to dive into it, but before we do that, let me just play the schedule of our live classes so you'll know when to tune in so you don't miss any. So right after that, we will get into our performance task, and the topic is limes for sale. Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. A new hat. Thank you. Now, another important. Have you ever gotten a math problem wrong simply by making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at common mistakes that students make with all the topics in CSEC math. We're going to look at common errors, demystify everything. Make sure you watch every video in this so that you can avoid making those mistakes. So stay tuned. Hello, scholars. Times when students get problems wrong in mathematics is as a result of one single error or one mistake. Well, this is absolutely true, and we're going to be looking at the common errors that students make in different topics in mathematics. With the errors behind, we can certainly avoid making them. Are you ready? Come on, take my hand. All right, guys, I want to also welcome my scholars who are in the chat, and I really do appreciate you being with us and sharing your responses, sharing your questions. So welcome Anusha, welcome Anjali, Adina or Adiana, I'm not sure how to pronounce your name, honey. Ashanti, welcome. We're doing fine, Ashanti. How are you? Good night. Now, I also want to welcome my in-studio scholars, and I'm going to invite them to come and share the screen with me. Welcome, Jer. Turn your camera on, please. Welcome, Madison. Welcome, Antoine. Welcome, Amari and John. Okay, so my scholars and I are ready, and so are my scholars who are in studio are ready, and so are my scholars in the chat. Wherever you are watching, wherever in the universe you're watching, I hope you have your book and pencil and you're ready to dive into the performance task. So I'm going to now share the screen so that you can see the all right, so it's for sale. Okay. So the performance task is written and is being presented by yours truly, Kamau Mahakoe. All right, so lines for sale. Let's get into the first. All right, Antoine, can you read that slide, please?
Okay, Miss. For PEP performance task, limes for sale. Camille spent the summer in Saint Anne, where her family has huge lime groves. She helped her cousins and the workers to pick the limes and package them for sale. PEP performance
Once
task.
again, please.
Okay,
Once
Miss.
again,
PEP
please.
performance task, limes for sale. Camille spent the summer in Saint Anne, where her family has huge lime groves. She helped her cousins and the workers to pick the limes and package them for sale.
All right. Amari, can you read the next slide, please?
Okay, miss. Limes for sale. Uncle Jed showed Camille how to fold the cardboard nets that would be used to make the rectangular carton boxes for the limes. Limes for sale. Uncle Jed showed Camille how to fold the cardboard nets that would be used to make the rectangular carton boxes for the limes.
When we talk about nets, what is that we're talking about?
Miss,
What do
in
we
my
mean?
own words, the nets mean the layout for the particular 3D shape.
Mhm. All right. So Antoine saying the net is a layout. Okay. Is there any other way that you would describe it? Anyone else? What is a net in terms of
Miss,
polygons and three-dimensional shapes? Madison, would you like to describe it or define
yes,
it?
miss. Um, it's kind of a map on how to fold the edges of the net to make a 3D shape.
Okay. All right. So both Antoine and Madison are correct. The net is a flat figure. It has two dimensions, but when you fold it along certain lines, you get a three-dimensional figure. So the net is a convenient way of shape, right? So you just cut out the net. You can have many, like a pattern, similar to what dressmakers use when they cut out a pattern for dresses. And then all you have to do is put the pattern onto a piece of cloth and cut around it. For as many times as you want, you'll have that pattern. So the net is a pattern. And we'll fold along the lines and then join certain faces together, and we will get three-dimensional shapes like cubes and cuboids or pyramids, cones. stuff like that. So Uncle Ed, he operates the farm with his family members, and they have boxes, cardboard boxes, rectangular in shape, so meaning they are cuboids, rectangular boxes to pack the lines. So here are the dimensions of each net. And your first task is on the cuboid, you are to write the dimensions from the net. So here is the net that goes to make this cuboid. So here we have 10 centimeters along this edge, 5 centimeters along this edge, and 9 centimeters along this edge. Now, when we're dealing with figures, wherever you see similar strokes, that means those lines are equal. So all the lines that have a single blue stroke, they are equal. So they are also 10 centimeters. Wherever you see the double red strokes, right, those are also 9 centimeters. And wherever you see the triple green strokes, those are all 5 centimeters. So you just need to fill in the measurements, the dimensions along the cuboid. Just, you don't have to put all of them, but just to show the length, the width, and the height. Okay? All right, so if I'm putting in the length, what would I put for the length based on the net?
Miss,
10
10
centimeters.
centimeters.
Does everybody agree the length is the same as this?
Yes, miss. I agree.
Okay, so that's 10 centimeters for the length. And what would be the width? That's this side here.
The 9 centimeters.
Would that be the width?
Miss 10 centimeters.
10 is the length.
Miss 5 is the width.
I would say 5 centimeters.
5 is the width, right? See, the 5 would go along that little part there. That's the width. So the 5 is the width. And what would be the height of the box?
Miss, the height will be 9 centimeters.
That's 9 centimeters. That's the height of the box, right? Same as this. Because remember, this part, this is the base, of the box. This part here is the base of the box. When we fold it, it's going to go under the bottom. And then this is going to go up to meet. This is the top of the box, right? So the height would be 9 centimeters. I can put it on this because the same 9 centimeters there, 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 and there. So 9 centimeters. So the length is, so that's the height, 9 centimeters. The length is centimeters. The width is 5 centimeters. So this is the base of the box right here. This is going to be folded under and be the other side. So this side facing this one. And these two sides would face each other here and here. This is the cover of the box, the top of the box. So based on those now, so remember 10 for the length, jot that down. 10 for the length, 5 for the width, and 9 for the height. So for 1A, what is the area of the base of the cuboid, the rectangular box? Hi, Alisa, welcome. It doesn't late than never. So Madison same 20. Remember,
No, miss, that
area
wasn't for
is
that.
in. What was it for?
Miss, it was for a different question. It was for the length question.
Oh, what? But none of them is 20 for the length.
Yes,
So what would
Miss.
be
I
the
was
area of
asking.
the base? I remember is in square units. What's the area of the base?
Miss 50 meters. I mean
The bottom,
centimeters squared.
Miss, Miss,
how
I
many?
50 centimeters squared.
Miss, I
50
agree.
centimeters square.
50
One,
centimeters. Yes,
because
Miss.
the length is 10 centimeters and the
And
width
the width
is
is 5
centimeters of the base, the
centimeters.
bottom of the box. Okay, so the area is 5. So what is the volume of the box? What's the volume of the box?
Miss, I never learned about how to find the
Miss,
value.
is it all of them? Is it length times? Sorry, not all of them. Length times width cubed.
Volume is length times width times height. The volume of a cuboid as well as a cube, length times width times height.
Miss, can you explain the volume to me, please?
Miss 450 cubed.
I just did Antoine.
Okay, Miss, sorry.
Miss
Centimeter cube. Volume
450
Antoine,
centimeter cubed.
volume is Madison. Correct. Volume is the space that is taken up on the inside of a three-dimensional shape. For the cube and the cuboid, the volume is the length times the width times the height. The concept of volume is the area of whatever the base is times. So if it's a cylinder, the volume would be the area of the base, which is a circle. The cylinder has a circular base. It would be times the height. If it's a triangle, if it's a prism, triangular prism, base times height, half for the base, the proper height, but on the base times the height of the prism itself. So whatever the base is, you use the for the base, whatever shape that base is, find the area of the base and multiply it by the height. That's the basic concept of volume. It's really how much space is on the inside or how much substance you can fill the inside of a shape with. That's the concept. Now the next question, 2A. If 1 dozen limes can hold in a 50 centimeter cube space, how many limes can hold in each box? So if 1 dozen limes can hold in a 50 centimeter cubed space, how many limes hold in each box? How do we approach the question?
Miss, I say to convert.
450 divided by 50.
And that would be your answer?
Miss, to get your
What,
answer.
Antoine? So Madison, you're 450 divided by 50 and that answer?
Yes, Miss, how to get the answer.
And Antoine, you're saying to
Miss, I say to convert the 1 dozen limes to digits, and that would be 12. 1 dozen equals 12.
Miss, I say 81 limes.
All right, now we just worked out that the space, the volume of each box is 450 centimeters cube, right? And 1 dozen limes, we all need limes. How many
12.
limes in a dozen?
12. 12.
12. So the base is 450 centimeters cube, and a 50 centimeter cube space can hold 12. So the would be to see how many 50 centimeter cube space are there in the 450 centimeters. I would divide the 450 by 50, as Madison said, but that wouldn't be my final answer. So that will give me nine 50 centimeter cube spaces in each box.
Listen,
And
multiply by
since centimeter
12.
cube is 12, right, so I would multiply the 9 by 12. I will get 108. So
Yes, miss.
108 limes can fit in each box. And the other question, the other part to number 2 says, how many boxes will be needed for 1,160, 2,160 limes? So we just found out that 108 limes can hold in each box. How many boxes will be needed for 260 limes?
Miss, how I how
Antoine?
I approach this question is to divide. Since question A said a- if a dozen limes can hold in a 50 centimeters cube box, so 50 centimeters cube box. So I would say to divide it 2,160 by 50.
Divide what?
Miss, I said 20.
Divide the 2,000. How you got 20?
Miss, I did 108 into 2,160.
All right, so that is correct. So Antoine is not to divide by the 50. We already used the 50 in the 450 to say it. There are 9 spaces. So 108 limes are in A. So when you see parts A, C, it's often the case where those answers that you worked earlier, you're going to need them for the next part. So you don't always have to be going from scratch. I worked out that there are 100 in each box. So how many limes, how many boxes would fit 2,160? We just need to divide the 2,160 by 8. Reduce it, you get your answer. If you can't go straight and by 108, some students can divide by 3-digit numbers, some can't as yet. If you can't, just keep reducing. So you cancel 160 and 108, divide by 2, go as low as you can until you get your answer. So the answer is 20. So Madison is correct. Okay, Amari, can you read question 3, please?
Okay, miss. Question 3. Limes for sale. There are 7 hikers working on pickers working on the street. The pickers are paid at a rate of $120 for every 5,000 limes picked. Camille wants to work out how much money the family would pay out for the week if each picker pick 600 lines every day.
Read it again.
Limes for sale. Question 3. There are 7 hired pickers working on the estate. The pickers are paid at a rate of $120 for every 5 dozen limes picked. Camille wants to work out how much money the family would pay out for the week if each picker picked 600 limes every day.
All right. So how can we approach this, Madison?
Miss, we find out how much is 5 dozens first, and 5 dozens is 60,
Mm-hmm.
and then
Okay.
we how did I do it? Miss, we find out how much 60 can go into 600, and I got 10, and then we'd multiply the amount of
Okay.
money by 10, and then the number that we got, we'd multiply by 7 since there are 7 hired pickers. And I got 8,400.
And is that your final answer?
Yes, miss.
But that would be for the day. They want for the week.
Oh, then miss multiply that by 7 again.
So do that and tell me what.
Miss 46,900.
So you're saying you multiply the 8,400 by 7 again.
Okay,
Check
miss.
your multiplication again.
Miss, I accidentally made my 8 look like a 6. So that's what threw me off.
So what's the number? So other scholars you can work it as well. Remember we said Madison said she first found out how many times are in the 5 dozen. So 5 times 12 is 6 times. And
Miss,
since you 6, yes, go ahead.
38,800.
No, still not right. Your calculation is off. All right, so 5 dozen limes, 120, right? And 5 dozen limes is 60. So if each worker picks 600 limes per day, so Madison is saying she divided the 600 by 60. So that's 10 times the 120 each worker would get, right? And which is 1,200. She multiplied that by 7 since it's 7 workers, and that gave 8,400. Now the final step is to multiply the 8,400 by 7 again, because they want for the week, and it's 7 days in the week, and we are not told that it's only a 5-day work week. If it was, we would multiply by 5, but maybe they work every day and then whatever, but we're not told that. So we're assuming for the week it will be times 7. Um, So that's where we're at. $8,400 times 7. Did you get your next answer, Madison? The first two were off. Our deals were out. 8,400. Come on, guys, that's not difficult to work. 8,400 times 7. Work out.
Miss, my answer when I work it out
Yes,
is
and
58,800.
Yes, miss, I got the same answer.
that's
Yes, I also
right.
got that one. Literally.
Okay, Jerry, can you go 4, please?
Okay, miss. How many of the boxes would be needed for all the limes picked for the week in question 3? How many of the boxes would be needed for all the limes picked for the week in question 3?
Okay. How many of the boxes would be needed for all the limes picked for the week in question 3?
Miss, can I say how we would get the answer?
Yes.
We divide 108 into 58,800 since one box holds 108.
Remember, the 58,000 was the money that we're paying the workers.
Oh, sorry, miss.
Okay.
Then we do that, but instead of 58,000,
So let's go
eight
back to this
hundred,
slide.
600.
Okay, so each worker picks 600 limes per day.
So, Miss, you will go about working that one out by dividing 600 by the, what's the number again?
Each worker picks 600 per day,
Yes, Miss.
and the question is asking how many of the boxes will be needed for all the limes picked for the week. So 600 per day times the 7 workers, which was 4,002, times the 7 days, right?
Yes,
So
Miss.
4,002 times 7 days. So that
Miss,
now,
I got 30.
so we're going to divide that by the 108. Is that what you did?
Yes,
Miss,
miss.
that's what I did.
1,200 divided by 108.
No, but the 4,200 was just for the 7 workers each day. We have to
Oh,
multiply that by 7 to get the week,
oh, okay.
and then we divide by 108. So the 4,200 times 7 would give what?
29,400.
Okay, and then we
Yes,
divide
Miss.
by the 108. Cancel it down as much as you can. If you can't divide by 3-digit number, cancel it down, reduce it, and tell me. You might have to round off the number. So what answer you get? So I got 272. Everybody got that?
Yes, miss. When I worked it out and set it out, I got it.
Okay. All right, so let's go on to number
What
5.
did you get again?
272 approximately. Let's go on to question 5. All right. Who hasn't read yet? Who hasn't read? John, you read already?
No, miss, I haven't read yet. You never hear.
Can you read? Can you read that question for me, please?
Okay, miss. Lambs for sale.
Well, this isn't really a question. It's just telling us information.
Okay, miss. Miss the statement then.
Yes, a
Lambs,
statement.
yes, lambs for sale. Camille decided to set up a lemonade stand where she sold lemonade that she made. She used all of her savings to buy 2 dozen limes and a bottle of honey. With all the ingredients, she made 15 liters of lemonade. Limes for sale. Camille decided to set up a lemonade stand where she sold lemonade that she made. She used all of her savings to buy 2 dozen limes and a bottle of honey. With all the ingredients, she made 15 liters of lemonade.
Read. How many times you read it? Twice? All right, so what are we going to do for that now?
Miss, it didn't ask us to do anything.
Let's go to the next one. Madison, read this one for me. Read that one.
Number 5. Camille sold the lemonade at $35 per cup, 200 milliliters, and $50 per large cup, 500 milliliters. The cups together cost her $300. She got the limes for free and she bought 2 bottles of honey with the rest of her savings. She sold 30 small cups and 18 large cups. If Camille made a profit of $1,000, what was the cost of each bottle of honey? Number 5.
Can't even do it.
Camille sold the lemonade at $35 per small cup, 200 ml, and $50 per large cup, 500 ml. The cups together cost her $300. She got the lamps for free and she bought 2 bottles of honey with the rest of her savings. She sold 30 small cups and 18 large cups. If Camille made a profit of $1,000, what was the cost of each bottle of honey?
All right, so tell me what to do for that now.
Miss,
Yes, Jer.
so what you would do, you would find the amount of cups that she sold
Mm-hmm.
in total. Miss, then you would add them together. And then if she had a profit of $1,000, you would subtract the answer you get from that $1,000.
Miss, I
Okay, so
agree
let's
on
subtract the
that.
answer from the profit.
No, miss.
All right, so let's take it step by step. Let's find out first how much she sold them. How much she sold them for, right?
Miss, she sold one small cup. She sold 30 small cups for 1,050 and 18 large cups for 900.
And when we add those up, how much we get? When we add those up.
Miss, you get 1,950.
All right. So that's what she made, right? That's what she made in all. So what did she spend? What did she spend in putting her stuff together? She bought the cups, don't it? How much she paid for the cups?
Miss, the question says $35 per small cup.
No. How much did she pay for the cups themselves? For the empty cup?
$300, miss.
Three,
Huh?
$300.
$300. Okay.
300
All right.
miss.
So she paid $300 for the cups, and so if we take out that $300 is one from the 1,950.
We get 1,650,
That's
miss.
1,650, and 1,000 out of that is profit, right?
Yes, miss.
So that means the 650 is what she paid for the 2 bottles of honey.
Yes, miss.
So how much was for one
Yes,
bottle of honey?
325.
325.
Correct. $325. So
yes,
let's go
agree.
from scratch again. Let's go from scratch. So we need to find out how much it cost her to make the lemonade, and then how much she made from the sales, and see take out how much of that was profit, and whatever was left back, that's what she paid for the honey, because it says she used up all of the rest of her savings on the honey. So is $35 for the small cup, and she sold 30 of those. So 30 times the 35, as Jer said, 1,050. And $50 she's selling the large cup of lemonade for, and she sold 18 of those. So 50 times the 18, that's 900. So we add those together. In all, she made 1,950. But we have to take out back the 300 that she spent. She took 300 of her money to buy the empty cups. And the $1,000 out of it is also profit, extra money that she made. That's what she earned. So whatever is left back from that would represent the cost of the 2 bottles of honey. So when we subtract the 300 and the 1,000, we get 650 left, and we divide that by 2, and that's 325. All right. I'm back to you. Question 6A, please. Are you there, Amari?
Miss, I think they're backstage still. They typed in the chat they were backstage.
Yes, miss, I saw that as
They
well.
got kicked off.
Yes, miss.
Jerry,
Okay, miss. What fraction of the lemonade was sold in the small cups? What percentage of the lemonade was sold in the large cups? Of the lemonade was sold in the small cup? What percentage of the lemonade was sold in the large cup?
okay, so what fraction of the lemonade was sold in small cups? Let's go back to that slide. the lemonade was sold in the store. This slide tells us she made 15 liters of lemonade in all, right? That's important. Jot that down. 15 liters of lemonade in all. And then the small cups were 200 milliliters. The large cup, 500 milliliters. She sold 30 of the small cups, 50 of the large cups. Jot down all of that information. Now we want to know what fraction of the lemonade was sold in the small cups. How do what of the lemonade was sold in the small
Miss,
cups?
may I try?
Jer?
Miss, let Madison go.
Madison, go.
Okay, Miss, thank you. Since she sold 30 small cups, we'd multiply 200 by 30 since it's 200 ml in every small cup. And then when we get our answer, we'd see how much of 15 liters that is. So we'd exchange the 15 liters into milliliters first.
Convert.
Yes, miss. Sorry, I couldn't find the right word.
How many milliliters? Okay, so how many milliliters is 15 liters?
1,000, Miss?
How many liters is 15 liters?
Miss,
1,000
with the
milliliters make 1 liter.
Miss,
15,000.
15,000
50,000 milliliters.
15,000.
15,000.
It's 15,000 liters of lemonade, and we're expressing the 35 times 200, the times 200, which is 6,000, right? So we're expressing 1,000 as a fraction of the 15,000, right? So what fraction? So just put 6,000 over 15,000 and reduce it. You can just cancel 3 zeros, top and bottom. You can do that with 0 and cancel them. 3 zeros at the top, 3 zeros at the bottom. You can
Excuse me, Miss,
cancel
would
them.
that be 16 over 6 over 15?
Reduce that still.
Two-thirds?
No, not 2/3.
Sorry, 2/5?
Correct. And the second part of the question says, what percentage of the lemonade was sold in the large cups?
Miss, never mind.
From the first answer, if 2 small cups, then it means what fraction was in the large cup, since it was all types of cups. If 2/5 was sold in the small cups, what fraction was sold in the large cups? One just express it as a percent. Or you can just go back and say for the large cups, 18 were sold and it's 500. Sorry, and 50 100 milliliters, sorry, and 18 were sold. So in times 500 would give 9,000. We can put that over the
Yes.
10,000 times 100. Either way, work it. What will be the answer for number 6? So we're saying if 2/5 was small, then 3/5 was large. And we're expressing 3/5 as a percent. 3 over 5 times 100. Or if we're doing it in terms of the milliliters, it would be 9,000 over 15,000 times 100. Nobody has the answer yet?
No, Miss, I'm still working, George.
Still working this.
3/5 times 100. 5 into 100 goes 20. 3 times 20.
60. 60%.
60%. That's the answer.
60%.
Correct. 60%. Read question 7, please.
Question 7. One lime makes 15 milliliters, 1 tablespoon of lime juice. A tablespoon is equivalent to 3 teaspoons. How many milliliters of lime juice would be in 18 teaspoons? Number 7. One lime makes 15 milliliters, 1 tablespoon of lime juice. A tablespoon is equivalent to 3 teaspoons. How many milliliters of lime juice would be in 18 teaspoons?
Yes, would
Okay,
that
what's
be
the answer for
9? Would that be
Pardon
9?
me?
Yes, would that be
9 milliliters? You're saying 9
Miss,
Miss,
milliliters?
Miss,
Yes.
would it be 54?
Or you got 54?
Miss, Miss, because if 1 tablespoon is equivalent to 3 um teaspoons,
Teaspoons.
and there are 18 teaspoons, you would divide your answer by 3, and you would have, Miss, I multiplied it by mistake, Miss. You would have to divide your answer by 3, and that would give you 6.
So you're saying it's 6 milliliters?
Miss, I also agree. I
Miss,
don't
Miss,
think
I got a different answer.
What did you get, Madison?
Miss, I got 108 because
108.
a tablespoon is equivalent to 3 teaspoons.
Mm-hmm.
So, um, I multiplied 18 by 6 for what Jared did. I did 3 into 18 and I multiplied it by 6.
3 into 18 goes 6 times. So that tells you how many tablespoons.
Yes,
That's
Miss, I'm now
converted.
realizing
So
how
what did
it's
you multiply now by the 6?
Miss 18, the 18 teaspoons.
So you divided 18 by 6 and now you're going to multiply it by 6? You're reversing the procedure that you did.
Yes, Miss.
No, but okay, so Jer, you're saying you converted the teaspoons to tablespoons. and you got 6 tablespoons. So go back now to the first part of the question. One lime makes 15 milliliters, which is 1 tablespoon. Oh, right? 15 milliliters is 1 tablespoon. So how many milliliters is 6 tablespoons? That's the question now. Because we just converted the 18 teaspoons to 6 tablespoons. So how many milliliters are in 6 tablespoons? If 15 milliliters is in 1 tablespoon. So 1 tablespoon is 15 milliliters. How
Miss,
many
it would be
milliliters?
90 because he would multiply 15 by 6.
Correct. It will be 90 milliliters. So 15 times 6. Jaden, can you read question 8, please?
Okay. Limes for sale. Number 8. Camille brought some bottles of lime juice for 3 of her teachers, her 2 best friends, and her principal. If each person received wait, if each person received 2 bottles, how many bottles did in all did Camille give away? Camille Camille
Camille?
Camille
Camille?
Camille brought some bottles of lime juice for 3 of her teachers, her 2 best friends, and her principal. If each person received 2 bottles, in all, how many bottles in all did Camille give away?
Miss,
Okay.
I say 12.
Okay, how you got 12, Madison?
Miss, I added 3 plus 2 plus 1 for 3 of her teachers, 2 of her friends, and her one principal. And I
Mm-hmm.
multiplied that by 2 since each person got 2 bottles. And I
All right.
got 12.
And that is correct.
Agree,
Okay.
miss. Okay, that's
Antoine, Antoine, question 9, please.
okay, miss. Pet performance task, lambs for sale. Number 9. If a liter jar of lime juice is 3/10 full, how many milliliters would be needed to completely fill the jar? If a liter jar of lime juice is 3/10 full, how many milliliters would be needed to completely fill the jar?
Okay. So 1 liter jar is 3/10 full. How many milliliters would we need to fill the jar?
7, 10.
Any thoughts on this one? How many milliliters? So remember 1,000 milliliters per liter.
Miss, 300.
So 3
800.
tenths of the liter jar. That would be 3 tenths. That would be how much is in. So how much is needed to?
Miss, I got 300 ml, but it's supposed to be
You got
700.
300 needed to fill.
700.
It will be
Miss, it's
700.
700 needed to
Miss,
fill
I
it.
say 700.
It has 300 in it, so it's 700.
Yes, miss.
Right. So 300 milliliters are in it.
Yes,
That's
miss. I
three
know
tenths
one.
of the liter.
When you add
And so,
700,
right, so we take that from the 1,000. All right, we have two questions. Question
Miss Amara
10,
and
please.
John, they're saying that they got 700 as well.
Okay, thank you,
Okay, miss.
Madison.
On average, each lime contains 17 seeds. About how many limes would give total of 340 seeds? On average, each lime contains 17 seeds. About how many limes would give total of 340 seeds? Miss,
Miss
would you
would
divide 17 into 340?
yes, Miss, and you will get 20.
yes, miss.
Correct. All
Mm.
right. And the last question, Jaden, please read. And remember, it's Camille.
Limes for sale, number 11. Camille used 4 lime leaves to make a cup of tea. How many leaves would she need to make tea for both her parents and 3 siblings? Number 11. Camille used 4 lime leaves to make a cup of tea. How many leaves would she need to make tea for both her parents and 3 siblings?
20 leaves, miss?
How you got 20, Jer?
Miss, I multiplied 4 leaves by 3 siblings, which would give you 12. Then I multiplied it by the 2 parents, which is 8. And
8.
then when you add them together, it gives you 20, miss.
Yes, miss. That's what I
Miss,
done.
I
I
did it
got
a
it.
different way.
Okay.
I added all of the people
You could
first
just add, right? You could add first
and then multiplied.
and then multiply. All right. So 20,
Yes, Miss, it's 20.
the end of the performance task. Yeah. End of the performance task for tonight. All right. So scholars, those in studio and those in the chat, time and the space. Remember, we have another PEP tomorrow. After that, 5 live PEP classes per Monday to Friday. All right. So I'll see you next night.
Good night, everybody.
Good night,
Good
everyone.
night.
Everybody, bye, Miss.
Bye.
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 Bye, one and
Bye.
all. Take care. See you
Bye.
tomorrow.
Bye, everyone.
Hello, CSEC math students. I know you are busy preparing your math tests, the CSEC exams coming up. I have a very, very important question to ask. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics, at the common errors, demystify everything. Make sure you watch watch every video in this series so you can avoid making those mistakes. So stay tuned. Hello scholars, you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake. Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If it was beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.